Okay, my name is Miguel Sorrolaza. I will be your teacher in this course, in this Code Aster course. And I will be your instructor. So I will guide you through the learning process for getting familiar with Code Aster. It is expected that you have some experience in finite element analysis. I mean, a basic background on finite element analysis, formulation, applications, and so on, and a little bit information and basic knowledge on CAD modeling, whichever software you want. It doesn't matter, but you need some experience in CAD modeling. Specialty is finite elements. I have more than 30 years of experience in finite element formulation and programming, and I am using Code Aster since several years. I'm very happy with Code Aster, as I will let you know during the course. This is a very, very useful open source code, and very powerful, of course. And I have used it during undergraduate and graduate finite element courses worldwide. Okay, so I hope you will enjoy the course. You know, which one is the course main objective? Okay, my main objective in this course is to provide you, to provide students with a basic intermediate level in Code Aster software for solving thermomechanical and engineering problems. As you know, well, if you don't know, you will know, Code Aster software is a software suitable, oriented towards the solution of thermomechanical problems. Mechanical problems and thermal problems and its coupling, okay? And then we can specify some, some specific objectives of our course, and I can summarize these specific objectives, in three main issues. Okay, first of all, to refresh knowledge on the finite element method. I repeat, I am assuming that you have a basic knowledge. If any of you has no enough basis or knowledge on finite element method, it will be not a big deal. Not a big problem. Okay, because you can contact me. I can provide you some further reading, additional information to reinforce your knowledge on finite elements. Okay, the second item or the second issue in our course is to learn basic modeling in Salome Mecha. I told you some minutes ago that it is expected that you have a basic knowledge on how to use any CAD software. Doesn't matter, any CAD software. It could be AutoCAD, FreeCAD, it could be even Salome Mecha. Okay, we are going to work in this course with Salome Mecha. And the main objective, specific objective, is to learn how to use Code Aster. Okay, I will be happy if I can give you the tools. Okay, the tools when you finish the course, if you have the tools to formulate and to solve a problem, a finite element, more or less complex problem, in using the Code Aster in the finite element Code Aster. What is this course and what it is not this course? This course is an introductory course on Code Aster software for finite element analysis. Just this, okay? No more than this. It's an introductory repeat course on Code Aster software for finite element analysis. I have to say that this is not a course on continuum mechanics. This is not a finite element course, and this is not a CAD course. These clarifications are needed because because someone could be a little bit confused during the course, because maybe someone can be expecting other things. Okay, so it should be clear that for everybody that this is an introductory course of Aster for solving finite element analysis engineering problems. The methodology that we will follow during the course is very simple. Okay, you will have conceptual, theoretical, explanatory sessions. Okay, these sessions are in a written material that you will have available when you come into the course. Okay, this material has some exercises. Okay, exercises solved in the written material, I mean. Okay, so you can follow the solution of these exercises and you can get familiarized with Aster software. But the main support for your learning in this course is your personal work. Okay, I mean, students' personal work is very, very important, and it is a key factor to get success during this kind of courses. And of course, in fourth place, you will have my advising and teacher support, because you can contact me by email and make questions and asking me problems and whatever, and I will answer you. Finite elements is the most powerful tool in engineering analysis and design nowadays. Up to now, I mean, there is no, up to my knowledge, okay, there is no company, no institution all over the world doing engineering analysis that is not using finite element or finite element technique or finite element codes or whatever. It means that since 1950s, since the 50s, when the finite element method was more or less invented and started to use, it's about 60 years. Okay, the method has evolved in a very, very impressive manner, and it's used to solve practically any kind of engineering problems. So it's very, very important that you should have a powerful tool, finite element code or finite element software, to solve your problems in engineering analysis. Of course, we have many other methods. We have boundary elements. I am also a specialist in boundary element, but this is not the objective of this course. Lattice-Boltzmann methods, which are mostly used for discrete domains, not continuous domains, okay? But they are not known as the finite element method is. Commercial software is very, very powerful. There exist a lot of impressive tools in the market right now. Where I can mention ANSYS, Cosmos, Abacus, Nastran, and so on, okay? Which are very friendly, a lot of interfaces, very friendly interfaces that make your life easier and easier and easier. But the problem is that this software they are costly tools. I mean, you have to pay, and in many cases you have to pay a lot of money. It means that surely, many small and medium companies all over the world can't afford commercial licenses because they are expensive. Okay, so this is the reason why open source software is becoming more and more used worldwide. Okay, so in this direction, and focusing in this course we are starting today, we are going, or we decided, we decided to use two main platforms, open source platforms. We decided to use, in first place, the Salome Mecha platform, which is an open software for CAD modeling. Okay, we will see this in a very in a much more detailed manner in the next sessions or in the written material. Okay, but you will use in this course the Salome Mecha platform, sorry, for CAD modeling, which is a very powerful, flexible platform offering you many options for modeling and for creating geometries, complex geometries, as much as you need them, and for meshing. Salome Mecha has very powerful meshing tools, probably one of the best I know up to my knowledge. Okay, so this is the reason we selected Salome Mecha platform. And in second place, we will use the Aster platform, which is the main core of this course. Okay, so the Aster software is a very powerful finer element software oriented to the thermomechanical analysis of continuous mechanics. This software was developed probably 20 or more years ago. It was developed by the National Electricity Company in France, Électricité de France, and this is a very powerful company, and they decided 20 or 25 years ago to create the software open software, sorry, for this purpose. Okay, and this is probably one of the software best maintained up to date. Okay, with several new versions, stable versions, beta versions, and regular versions. Okay, so we will use the latest stable version. If I remember well, it's the 14.4 Aster version. Okay, but in general, you should know in this introductory video, Aster software is a very powerful, flexible, and magnificent tool for solving finite element problems, engineering practice finite element problems. The software offers you a lot of options, including mechanical analysis related to the linear analysis, non-linear domains, static, dynamic, modal analysis, fracture, damage, fatigue, couplet problems, mechanical and fluid structure problems. And on the other side, you will find a lot of interesting options for doing thermal analysis. Thermal analysis with conduction, convection, radiation in a stationary regime, transient regime, phase changes, nonlinear boundary conditions, and so on. And other types of analysis are also possible in Aster software. You can do soil structure interaction. You can make a very advanced analysis of concrete structures, considering the microstructure of the domain. You can carry on metallurgical analysis, welding problems, and acoustic problems. Okay, so once you will get familiarized with the Aster, you should learn to write the files required to run the software. And then the next step is to show you which will be our course topics in our Aster software. Okay.